In this video, we'll be doing transformations of sinusoidal functions. And by the end of the video, you'll be able to graph the sine and cosine function with vertical and horizontal stretches, compressions, and reflections, and with vertical and horizontal shifts. Here's a little summary of our transformations. So we have our sine function and then our cosine functions with all of our transformations. A is a vertical stretch or compression, and it also is a reflection in our x-axis. The absolute value of A is our amplitude. K is a horizontal stretch or compression or a reflection in the y-axis. And the period is 360 divided by the absolute value of K. D is known as our phase shift. This is just our horizontal shift from left to right. And C is our vertical displacement, otherwise known as our vertical shift. I'm going to show you two different methods that you can use to graph the sinusoidal functions. The first is to use the suggested order. So our first step is to graph our cycles with the correct amplitude and period. Then you're going to reflect your graph in the x or y axis if it's necessary. And then we're going to do our shifts, our horizontal and vertical shifts. So here's our first example, and this is the cosine function that we're going to graph. Let's start off by labeling A, K, D, and C. So there's a negative in front of our cosine, which means our value for A is -1. And the amplitude is just the absolute value of A. So our amplitude is 1, and it hasn't changed from our regular cosine function. Since the value of A in our function is negative, that means there's a reflection. It's going to be a reflection in the x-axis. The value of K in our function is 2, and to find our period, we need to do 360 divided by 2, and that gives us our new period. So 360 divided by 2 is just 180 degrees. So the period of one cycle has actually gotten smaller. It's been compressed by a factor of 2. In this example, we're being asked to graph 2 complete cycles. So if one cycle is 180 degrees, that means 2 cycles is going to take 360 degrees. So we're going to base our domain of this function on our 2 cycles only. So 2 cycles of our new period would give us a minimum x value of 0, and then a maximum x value of 360. There's a phase shift here because d is not equal to 0, d is equal to 180. So this whole graph is going to shift right 180 degrees. So that means our minimum x value and our maximum x value of these 2 cycles is going to change, and we can add 180 to these. So then our minimum x value is now 180, and our maximum x value is now 540. And now what do we have left in our equation? Well, we have this plus 2 at the end. This is our C value. So this is going to shift our entire graph up 2 units. So if our original maximum y value is 1, then we can add 2 to 1. And that'll give us our new maximum value, which is 3. And we would do the same thing for our minimum value. And now you need to fill in your scale on your graph. So you need to make sure that on our y-axis, you can fit your maximum and your minimum between 1 and 3. So our maximum here would be 3. And then on our x-axis, we need to be able to fit 2 cycles on here from 180 degrees to 540 degrees. So here's the scale I'm using, and I know I can fit a maximum of 3 on our y-axis, and then 2 cycles at a maximum of 540 on our x-axis. Our first step is to graph 2 cycles using the correct amplitude and period. So our amplitude is 1, and our period is 180 degrees. So since this is the cosine function, we're going to start at our maximum point of 1 and end at our maximum point of 1. And that would be 1 period. And I know halfway in between the cosine function At 90 degrees, we're at our minimum at -1. And at 1/4, we're just at the x-axis, or our axis of the curve. And at 3/4, we're also at the axis of curve. So this is our one cycle of the cosine function. And then we can follow that and draw the next cycle. And this is just y equals cosine of 2x, which just includes our horizontal compression. Next, we're going to draw our graph with any reflections in the x or y axis, and we do know that there is a reflection in the x-axis. Our a value is negative, so that means our graph reflects vertically. So all of these points are going to appear on the other side of the x-axis. So instead of at 1, we're at -1, and all of these just flip to the other side. And the only points that aren't changing right now are x-intercepts. So here's our new function. And again, this isn't our completely transformed function because we are just doing this in steps for now. So our orange graph is just y equals negative cosine of 2x. And now I'm going to draw the graph one more time, but the fully transformed function, which includes our vertical and horizontal shifts. So we're going to take all of our points from our most recent graph and then move them right 180 degrees and move them up 2 units. But you need to keep in mind your scale here. So in my scale, every 4 boxes is 90 degrees. So that means every 8 boxes on my x-axis is 180 degrees. And on my y-axis, every 2 boxes is 1 unit. So I'm going to take every point, I'm going to start with this bottom point, and go to the right 8 boxes, that's 180 degrees, and I'm going up 4 boxes, because that's 2 units. So that means my new point, and I'm going to draw in blue here, my new point will be right here. And we're going to do that with all of our points. So in blue, we have our fully transformed function. Now let's complete our domain and range. So for our domain, you should know that for any sinusoidal functions, this will continue on forever. And it would normally be x is an element of real numbers, but we're just going to write the domain for our 2 cycles because we're only asked to complete 2 cycles. So the domain for 2 cycles, it will still include that x is an element of real numbers, such that we need to include our maximum and minimum values here. So x is going to be greater or equal to 180 degrees, but less than or equal to 540 degrees. And that's our domain. And our range is going to change because we've shifted the entire graph up. So y is still going to be an element of real numbers, such that y is greater or equal to 1, but less than or equal to 3. And there you have it, we're done. So if you like that method, you can go ahead and continue using this method for any other questions. Otherwise, you could continue watching for a different method that I personally like to use when I'm graphing sinusoidal functions. And here's our next example. So let's list off A, K, D, and C. A is -2, K is 1/2, D is 60, and C is -1. And you know what, I'm just going to rewrite that off to the side. So A is -2, K is 1/2, D is 60, it's a positive 60, so we're going right, and C is a -1. So we know that the absolute value of A is just our amplitude. So our amplitude is a +2. And our period is affected by K. So if we do 360, divide that by 1/2, we're going to get a bigger period. We're actually going to get a period of 720. So I'm just going to write what happens at the top beside these letters. So A, that's a stretch. It's a vertical stretch by a factor of 2. And since it's negative, it's also a reflection in the x-axis. And then our k value, that changes our period. So I'm just going to write period of 720. This is a horizontal stretch. And this d value makes us go right 60 units. And for our c value, our c value was a -1. So that means this shifts our graph down 1 unit. So we're being asked to graph 1 complete cycle. So the maximum x value would be 720. But since there is a horizontal shift, a phase shift of 60 degrees to the right, we can add 60 to that, and that would be our new maximum. So 720 plus 60 is 780. So we need to make sure that our x-axis fits 780 degrees. And that's why I write this out, so it helps us plan out our scale so we can draw this graph appropriately. And for a range, so for a range we need to use our amplitude and our c value. And you don't necessarily have to write your maximum and your minimum value here. So for instance, for my range to view where my y values are going to be, because the graph is going down because c is negative, I'm going to focus on the minimum. And our regular minimum y value is a -1, but because we have an a value of 2, we would be multiplying all of those values by 2. So our minimum, without any shifts, our minimum y value would be a -2, and then when we shift down, we're going to be subtracting 1. So that means our new minimum is going to be at a -3. So we need to make sure -3 fits on our y-axis. So pause the video and try to draw your own scale. So here's the scale I'm using. On the x-axis, every 2 boxes is 60 degrees, and on the y-axis, every 2 boxes is 1 unit. So when I draw transformations, I like to start off with the axis of the curve, just as a guideline. So the axis of the curve is always that line that will split your sinusoidal function in half vertically. So your value of c is actually the same value of your axis of the curve, because originally our axis of the curve is at y = 0. But since c moves our graph up or down, that will move the axis of the curve up or down. So our axis of the curve, our new axis of the curve, is at y = -1. Next, I'm going to use my 2 endpoints of one cycle. So we're graphing the sine function. So this is what the sine function looks like. And at each end of one cycle, we're at the axis of the curve. So I know that I can use my axis of the curve and draw my 2 points there. Now I need to look at my period. So our period is 720 degrees. So using that period along with our phase shift, you can draw your 2 points. So instead of drawing it at my axis at 0, because we're shifting the graph right 60, at the axis we're going to draw it at 60 degrees. And then at the end of the cycle, it's not going to be at 720 degrees. We need to draw it at 780 degrees because we've shifted that point as well 60 degrees. So these are my 2 endpoints. And since this is a sine curve, right at the halfway mark of our cycle, there is another point at the axis of the curve. So right here at 420, we have another point. And now we need to draw our maximum and our minimum points. But first, it's actually really helpful if you just take your one cycle and then split it up into quarters. So here are the quarters of our cycle. the graph of the sine function is always going to start at the axis of the curve and then go up to our maximum, unless there is a vertical reflection, a reflection in the x-axis, because then this is going to flip all of our y values. Since our value of a is -2, that means we're going from the axis of the curve to our minimum and then back to the axis. And we also need to use our amplitude here. So our amplitude is 2. So instead of going 1 unit down to our minimum, we would go 2 units down to our minimum. So that means we would have a point right here at 1/4 at our minimum of -3. And then at 3/4, we would also have our maximum point, and this is going to be at 1. So these are our key points for this function. And let's just draw this curve. And there you have it. That is our sine function. That's one cycle of our sine function. And now let's complete the domain and range. So the domain for this function, for one cycle of this function, is going to be x is an element of real numbers such that x is going to be greater or equal to 60 and less than or equal to 780. And then our range is all our possible y values for this one cycle. So y is an element of real numbers such that y is greater or equal to -3, but less than or equal to 1. Here's our final example, and I want you to try this one on your own. So you've seen 2 different methods. Use the method that works better for you. And instead of sine, we're actually going to change this graph to cos. Now here's a hint. Remember when we started transformations of all types of functions? Our k value needs to be factored. Factor out this 2 before you actually do your transformations. So pause the video, go ahead and do this on your own, and then come back to check your graph. So I started off by organizing all our information, but first, you have to factor out this 2 to find this true value of our d. So our a value is at 0.5, this was a vertical compression. We have a k value of 2, which is a horizontal compression. It turns our period into 180 degrees. Our new d value, or a true d value, is 30, so we're going to move this graph right 30 degrees, and we have a c value of -1, so we're moving this graph down 1 unit. So I changed this graph into the cosine function so we can use this method with this function, and the cosine function looks like that. And we're going to start off with our axis of the curve. So remember, this value of c would be the same as our axis of the curve. So that's at -1. So right here, this is where our function would split in half vertically. Since we're drawing the cosine function, our endpoints of one cycle are not going to be at the axis of the curve. They're actually going to be at the maximum. Since our amplitude is 0.5, 0.5 units up from our axis of the curve is going to be where our maximum is. Before we draw our endpoints, we need to use our period and our phase shift to determine exactly where our endpoints are. So instead of being at 0, we're going to shift over 30 degrees to the right. So our maximum point, the endpoint of this function, would be right here at 30 and 0.5. And then instead of being at 180 degrees, we're shifting 30 degrees to the right, so that's at 210. So that would be our second endpoint, which is at a maximum right here. And if it helps, you can split this graph in quarters. And this just splits one cycle into sections so you can easily graph the other key points. So halfway in this graph, you're going to have a minimum point because this is the cosine function. And then at 1/4 and at 3/4, we have our key points that are at the axis of the curve. So here is our cosine function. There you go, and that's one cycle of this complete cosine function. Now go ahead and write out your domain and your range. And if you want a little more practice, go ahead and draw this function again as the sine function. Practice is really important when it comes to transformations of any function, really, because the more you practice, the easier it will be for you, and you'll be able to find new tips and tricks that will work better for you.